Hi everyone. So today I'm going to explain my solution for Codeforces round 1072, that is div 3. So let's start. I have solved 5 problems and 4 in contest. My one of the last problem, that is the execute array, got accepted I guess 5 to 6 minutes after the contest. So yeah. So starting with the social experiment, the problem is that we are given n. We can make groups of either 2 people or 3 people, and basically after forming the groups we divide them, we send them into group A or group B. I say there are n equal to 4 people, we can create either, I mean here we have only choice of 2 and 2, as there can't be 3 and 1. 3 and 1 is not a possible solution. Say n equal to, we say 8, then we can have groups like 2, 2, 2 and 2, or we can have 3, 3, 2. Is there any possible other groups? 2, then I have 6, yeah, 2, 3, 3 I covered. If I get 3, 5, yeah, these are 2 possible groups. So one thing, I mean there are after creating group there are 2 civilizations, say civilization A and civilization B. I can either send for each of the group I can either send them to A or B. Say for this I choose the group number 1 to go to A, so A total count becomes 2. I chose number 2 to go to B, the B's total count become 2. I chose 3 to be in A and 4 to in B. So both A and B have 4, and we have to report the minimum possible difference in the civilization. Here the case is 0, right? If I choose this certain combination, I can have 3, 2, 3, or I have 3, 3, 2, comma 0. Then here it would be 5, 3, the difference it would be 2, right? The absolute difference, or here it is 8 and 0, that is 8. Or I can have 3, 3 and 2 that have like 4, right? So out of all this possible type of combination and all those things, we have to report the minimum difference between the summation of the number members in both the civilization, right? So it's I mean, if you see, if n equal to 2, there is only one possible choice, that is make a group 2 and assign it to either of one of the group, right? So making the minimum absolute difference to be 2. And from this point onward, if say n equal to 3, I can have 3, and I can only assign it to one of the group, making the minimum difference to be 3. From 3 and so forth, if I have say n equal to 4, a clever idea is to make 2 comma 2, and the absolute difference would be 0, right? If n is equal to 5, what I'm doing, I'll be making 3 and 2, so the absolute difference would be 1. Here it will be 0. For n equal to 6, I can make 3 comma 3, right? The absolute difference would be 0 again. If n is equal to 7, now I can't make 3 or 4, 3 and 4, right? Or can we? Yeah, I can. I would be wanting to have 3 comma 4, but I can't make a group of 4, rather I can make group of 2 comma 2, right? So the difference would be 0. Sorry, difference would be 1, my bad. Absolute of 3 minus 4 is 1, right? If n is equal to 8, I want to make 4 comma 4, that I can represent in 2 comma 2, again 2 comma 2, the absolute difference leading to 0, which gives a simpler solution that if my n is less than equal to 3, report n, else it's if n is odd, report 1, or if n is even, report 0. That's it. I hope we understood problem A. Moving forward to problem B. Uh, what do we have? An hourglass, right? So it's an, I mean, good observation-based problem, I would say. We have okay. So we have an hourglass, right? It measures s minutes, um, and say it is full by say, or rather, how would I represent? It was something like this: at t equal to 0, for t till m minutes. Oh, my bad. M minutes. What I would do is that for every k minutes starting from t equal to 0, I mean from at t equal to 0, I'll flip it, and after k minutes, every k minute I would flip it again, right? And I have to report after m minutes, uh, say after m minutes, my hourglass state is something like this. We have few sand at top and the remaining is settled. It can be one of the possibility. There can be a possibility where it is completely empty and all of my sand settle down at bottom, right? So after what we have to output is that to output after m minutes, for how many more minutes will the sand will fall, right? Say after m minutes I have sand, the value of the sand here is 5 minutes more, so it would be falling for 5 more minutes. I hope you get the gist. Better we understand with an example, that would be better. Say we have s equal to 8, k equal to 8, and my m, that would be equal to is 12, right? So initially my hourglass is like this. I would be flipping it, so it starts, and exactly after 8 minutes it would be completely at bottom. My entire sand would be after bottom at t equal to 8. I would flip it again at t equal to 8, right? And at t equal to 12, 4 minutes of sand has been already been settled up, and there will be sand remaining which will fall for more 4 minutes, right? So leading a result to be 4. Okay, I mean at 0, at t equal to 0, I flipped it for the first time, right? Then for t is equal to 8, I flipped it again. At t equal to 12, 4 minutes of sand has already been fallen down, and we have 4 minutes of sand remaining, right? So that's what input and output, and what um, should we report, right? um, the thing is, how are we gonna proceed? There can be two things, right? If my k is greater than s, or if my k is less than s. Okay, so starting with my k is greater than equal to s, right? Okay, my here my k is greater than equal to s. Okay, so we know, we can determine f, that is the number of flips, would be m by k, and I say remaining minutes is m percentage k. One thing we know, if remaining is equal to 0, I mean at my last minute I'd be flipping it again, so it would be entirely falling entirely for s, right? If rem is equal to 0, um, then the entire s will be follow, so it would be reporting s. Okay, and if my rem else or rem is not equal to 0, then my result would be max of 0 comma s minus rem. As you know, every m minutes, every k minutes we are flipping it again, and remaining is the number of minutes remaining, right? If my s is my rem is 0, I mean, honestly we don't need this sentence, but yeah, I mean, it's all right. If we just ignore this, the result would be, again here rem would be 0, and the remaining the result would in turn become s, right? So yeah, so our result is max of 0 comma s minus rem, as after k times I'd be flipping it, after one of the factors of k, I'd be flipping it again, it's the last factor, and there are m minutes remaining. So out of my s minutes, my rem minutes would be, I'll be allowing it to settle it down, and the remaining sand out of s minus rem would be falling down. If s minus rem is less than 0, then there will be 0 amount of sand falling down, resulting our answer to be 0. I hope it's clear. Moving forward with the case, that is k is less than s. Okay, so for k less than equal to s, we have to notice one more thing. Say what will be happening at my first turn. Say my k is my s is say 8 and my k is 3. So at first turn, I'd be allowing my sand to fall for 3 minutes. Here it would be 3 minutes, and here it would be 5 minutes, right? At my flip count equal to 1. Say at flip count equal to 2, I'd be reversing it, and again after t equal to t equal to 0, or say my t is equal to 3, or and then t is equal to 6, I'd be having something like this: 8, and here it would be 0, right? Because I'd be turning this upside down. So my sand of amount 3 would be falling down 3 minutes, and the 5 would be already at bottom, so it would be 8 and it would be 0, right? So one thing we infer is that if number of flips are even, right, then my result would be as similar to that with k is greater than equal to s, that is 0 comma what was again s minus rem. And if f is odd, then rather than of s, then the result would be equal to 0 comma k minus rem, because if it is odd, we know that for one turn, for the odd turn, we would be allowing it to fall completely. Here it fell for 3 minutes, that is equivalent to k, so we have k minus rem. I hope you understood. I mean, the implementation is simple. We do this, and wow, we are at this point. Moving forward to the third case, third question. We have problem C. You can read the problem. Basically, the problem states that we have n apples. What we can do is that we divide n into n by 2 and n by 2 apples. The notation are bit weird, but I mean not bit weird, bit standard, but yeah, what it means to say is that if n is even, then make it into an even. Say n is 14, we make it into 7, and if n is equal to 15, we make into 7 and 8, right? That's simple. And we are given a k. um, we have to tell if you know if it is by dividing it in certain ways we'll reach a point where um, we'll reach k. Say my n is equal to 30 and k is equal to 8. Then after one turn I would be having 15 and 15, and after two turns, I mean if I divide this in further, I would be getting 8 and 7, so my result would be 2. I mean how many turns it took for me, the minimum turns it took for me to reach 8, or we have to report that we never reach the point k. Say if for same n equal to 30, or rather say n equal to 30 and my k equal to 9, I would never reach a point where I'll be having um, my partitions to be 9. You can try it alone. I mean, say 30, you can have go to 15 and 15. This side will be equivalent. We'll be having 8 and 7. Again, we having 3 and 4, 2 and 2, 2 and 1, 4 and 4, 2, 2, 1 and 1. So you see, we never reach k equal to 9. I mean, this 15 is as equivalent as this 4 is as equivalent as that. For to reach 15 we have 1, to reach 8 we have 2, to reach 7 we have 2, to reach 3 um, we are taking 3 turns. Say first turn I would be dividing this, second turn I am dividing these two, third turn I would be dividing this, right? I hope you got the idea, and if you just analyze it, it's just in tree. You can have DFS and you could store these states in an DP, or say map of LL, LLMP, and that's pretty much it. It's a standard DFS, and you're just checking if we have something in map. If we have that number in map, we are returning back from the call routine, and else we're storing it and then we're proceeding further. So the one key question is should get is that how many states are in my DP, right? Say the numbers n could be pretty large, is less than, sorry, n is less than equal to 189, right? So you you must think like how big can my this thing goes, right? MP can go. So the upper bound for MP would be log n, because at every state, every step, you are because at every step you are diverging the tree, right? Which is say Tn equal to 2 Tn by 2. I mean, say here you have n number of terms that you represent as Tn, um, that you represent by, at max you can have 2 times, I mean identical to these things, right? So you have 2 Tn n by 2, and this series as we expand it goes to log n. So yeah, say I have, no, I mean it is n log n, I guess. Series yeah, it's yeah, it's login and login. Yeah, so that, I mean, I don't think it's n login. Yeah, I think it's I don't know. That's two into yeah n की power k. 2 into 2 की power k. Q would be um Q would be. I'd ask ChatGPT. Say words summation of pn equal to pn by 2. I don't know. K equal to login. O of n. Hmm. Hmm. Yeah, okay. Yeah. We are going login steps. Yeah. Yeah. I mean, okay. So the depth is login, and you know, most of the trees starting, if we start at a higher index, most of the trees overlap, and even at smaller index, many of the subtrees overlap. So, mm, I mean, you'd still be having less than n elements, right? And once an element overlaps, you just completely overlap. Uh, say d is at d, and 2 to the power d minus 1 elements, you just overlap, and that's a huge number. So you eventually make it up. I mean, I would also go and do some calculations to find out how exactly was the exact complexity or refer tutorial, but yeah, this works. Coming to the fourth problem, the unfair game. Yeah, it's an I mean, it's a good question, I would say. Say that this one. So yeah, so we can read the question, and it's a pretty huge question. The things we just require is that we know that n is equal to 2 raised to the power d, and yeah, the fact that Alice knows whether the chosen number is even or not is also one more help which we should focus upon. And then yeah, pretty much it. So starting with the fact that n, just be remembering n is equal to the power d, and then Alice knows if the chosen number the number is either odd or even. Do we have text in here? No, we don't. Anyways, just how many minutes have it passed? I don't know, but yeah, B. Alice knows. Okay, so the thing is, if I give you a number, say 7, so first you try to figure how many um, turn Alice would take, how many minimum number of turns Alice would. First, you go read the question, alright? Then, once you read the question, just let me know. Say for number 7, how many minimum turns Alice would require to win, right? Say, I mean, you can pause the video, you could just figure it out yourself. But if you write 7 in, say, uh, in what do you say, binary format? Yeah, binary format. Then 7 can be represented as this, and the minimum number of turns Alice should be taking is that, say, 2, 1 and 2, 3 and 4, and then so Alice should be taking 5 turns, right? So how is 5? So for removing this one, it is Alice know it's an odd, so Alice should be subtracting 1, then dividing it again, subtracting 1, dividing it. I mean, there are enough clues that he would be giving, right? The one clue that is essential is that for 1, Alice knows it is 1, so she could just subtract 1 from it and reach 0, right? So the number of turns should be taking 1. So if you know, for this number, similarly for 8, it is 1 0 0 0. How many turns? For removing 0, it is 1, then 2, then 3, and then 4. 4 turns, right? Okay, so if you are able to figure for each number, now let's start and start figuring out how can we find the total number of numbers of, say, for 1 to n, how many numbers for each number in 1 to n. What is the minimum number of turns required? And for, say, you are given 7, and then you know that the number of turns, that is k is 8, then you definitely know 8 is greater than or equal to 7, so Alice would be suffice to reach 7, and Alice would be guessing 7 out. Let's focus on single number. Then now, once we've found out the trick for the single number, let's start finding it out for the entire 1 to n, right? And we for sure know that n is a power of 2. Could be thinking how it's gonna help, but let's soon get to know. Alright, say for n equal to, or I mean, we're representing number as 1 to n, rather than representing it as in 1 to n. I'd be representing it in number 1 to d bits, right? Say I say d bits. How many number can I have for d bit? 2 to the power d 2 to the power d plus 1 minus 1. I hope we are on the same page for it. Yeah, so for 1 bit, I just have single 1 that takes turn. It requires minimum of 1 turn to get through, or at least to guess. Say now I increase to 2 bit. What relation can I impose, right? It is 1. So for 1, I can either have, 1 for the second bit. What I can have 2 or 3. Say 2 to the power d, that is 2 to 2 की power d plus 1, that is 4 minus 1 3. For 2 it is how many terms? It is 2. For 3 it is 1 and 1. That would be 3 turns, right? Now let's just it is for d equal to 2, right? So can we just move forward and make the same thing for d equal to 3? Let's just do it here. D equal to 1, we have 1 which take 1 turn. For d equal to 2, we have 1 and 1 which takes 3 turns, and 1 and 0 which take 2 turns. For d equal to 3, we have let's start with d equal to 2. We have 1 and 1 which takes 5 turns. We have 1 1 0 which take 4 turns. Then I can have 1 0 1 which again take 1 2 3, no, it's 2 3 4, yeah, it's 4 turns. And then obviously we have 1 0 0 which again take 3 turns. I hope yeah, write it better. 1 0 0 which take 3 turns, right? I hope you guys are getting it right. So how we reached here, if you see, just leave this as of now. I'll come to say how. Okay, can we see some common thing? I mean, we had 1 and 1, right? At here we just added another 1, so the value increased by 2. We had 1 and 0, we added one more 1, so the value increased by 1. Then you'd say, then okay, cool, then where is 0 and 1? It is exactly here. We just had 1, right? But we added one more 0, and then we put 1 1. I mean, we had 1, put one more 0, then we added 1. We know for this 1 we require two terms, extra turns. For 0 we require 1 turn, right? So we added 3 plus 1 4. And if I know this bit index is 3 and this bit index is 1, then the extra number of 0 I will be requiring is that 3 minus 1 minus 1, or say j minus I minus 1, and 1 bit I'll be making it as in 1. If we are able to pre-calculate these, and someone asks for me to find the number of say he gives me an n which is an maximum bit index or is of n bits, say he asks me to of 5 bits, or it is 2 to the power 5, then I will be calculating for I equal to 1 to I less than equal to j yj, because I would just having in case of j I would only having this one element, and then I would be having all smaller elements than j, which is encapsulated inside 2 to the power d minus 1, which is exactly what we are calculating, right? So for I equal to 1, I less than equal to j I plus plus, I would be checking if a particular number is less than equal to k, I mean if 1 is less than equal to number 1 takes how many turns? 1 turn. If 1 is less than equal to k, would be adding it to Alice, and after that n minus Alice would be score of Bob. But this loop is not very efficient, so it would be pre-calculating here itself. So how we are gonna do that is that I just took 64 randomly. You could have 32, 10 to the power 9 suffice at 32, and for each j equal to 1, as I said earlier, the number of extra zeros we need to put in is I minus j minus 1. Then for each VMP or vector of map, IT of first, that is the score of the number of turns it takes, plus 2, that is the 1 bit we are adding as an to make it a 5-bit number, or say j bit or I bit number, plus diff is number of zeros we are adding extra. And then at VMP II is 1. As you can see, I said leave 100 for right now. You can take any d bit number or 2 to the power d. It would be requiring d bits, right? Say 1, 2 and 3. That's pretty much the idea behind it. And then you're just going t equal to 1 to idx bit. You're just calculating here. The one thing you should always remember is that this contains 1 to 2 to the power d minus 1, but the same thing, but you have to also check for 2 raised to the power d. That can be checked by if k is greater than or equal to idx plus 1, and if it the case, or reduce result by 1. Result here refers to Bob's score, and if you can get something, I mean if k is greater than or equal to the number of turns it required for a number to reach, it goes to Alice, so the result reduces, right? And if we made this far into this video, would be just going over ProblemE, which is kind of simple, and it uses certain things. Would just be going upon that, and then the solution become inherently easy. So you know the drill. You should, I mean, the problem is simple. You could just go give it a read. The one thing I got confused for say 5 minutes was the thing I thought k is k is the length of subarray. Rather, k is you just don't get confused, right? You just read the problem statements once or twice. I hope you are better than me and you'll figure it out what k means. The thing is, to find a k execute array, we first would love to calculate the difference array. The difference array would be size n minus 1, right? And once we find the difference array, say the difference array looks something like 3, 2, 4, then 1, something like this, right? And I need to find the number of different all k execute array, right? So how many 4k execute array would be? Like, I could take 4. I could only have 4, right? Because this is a difference array. This is difference array. This is not the original array. This is a difference array. So I could only have 4. Okay, I would be saying it's fine. Okay, so how many 3 index or 3 execute array I could have. It could only be having one sub-arrays, not arrays, sub-array. Then the question is how many two execute sub-arrays I would have. Okay, I said I can take this. I can also have this. I can also have this, right? Um, so in left I have two choices. I mean, I can either take this or leave this. And again in right I have two choices. I can either take this or leave this. So the total number of sub-arrays would be 4, right? I hope you get the idea. I mean, if any array is k execute sub-array, then it is definitely k minus 1 execute sub-array. It could be k minus 2 execute sub-array till 1, right? And yeah, you just find the next or the previous smaller index and the next smaller index, and then your left choices would be number of the left, the previous, I mean the difference, the number of elements here plus 1, and the right would be number of elements between here and plus 1, and then you'd be doing a result of 2, that is the difference, or a result of diff of I plus equal to left into right. I'm sorry if I was unable to explain this quite well, because yeah, I'm already tired, and I hope, I mean, the problem is bit simple. I hope you get the gist of it. That's all for this video. Thank you.